Hello students, let's continue the questions. 1 liter atmosphere is equal to 0.0242 kilocal or 24.2 cal. So the answer here is third option. For the formation of HCl, let's write the reaction for the formation of HCl. So you have to write the equation for 1 mole. So it will be half H2. You have to write the physical states also, students, because you have to calculate the number of moles. So the reaction is like this: half H2 plus half Cl2 giving 1 mole of HCl. If you calculate delta N here, what is delta N? Delta N is the number of moles of the gaseous products minus the number of moles of the gaseous reactant. So half plus half will become 1. Here delta N comes out to 0. Students, always remember, if the delta N value comes out to 0, means delta H is equal to delta U. If the value comes out to be positive, delta H is greater than delta U, and if it is negative, then delta U is greater than delta H. So according to this, as we got delta N 0, therefore delta H is equal to delta U. Answer is third option. Let's see the next one. If delta E is the heat of reaction for this given reaction at constant volume, the delta H of the reaction at constant pressure at constant temperature is. Now if you see the equations, they have given the enthalpy equations for a chemical reaction. So what is the equation, student? Delta H is equal to delta U plus delta N RT. You have to just calculate delta N. If you see the reaction, you have to consider only the gaseous reactants and the gaseous products. So on the product side, there are 2 moles of carbon dioxide. Therefore, delta N is equal to 2 minus. Now, if you see the product side, there is only one gaseous, that is oxygen, which is 3 moles. So, it will be minus 3. So, delta N what you got is minus 1. So, you will replace this by minus 1. So, your answer will be delta H is equal to delta U minus 1 RT or RT. So, the answer here is second option. Let's see the next question. What is the value of delta N for the formation of acetaldehyde from the constituent elements? What is acetaldehyde, student? Acetaldehyde is CH3CHO. Now this exists in the liquid state. So let us write the equation first. So it will be C plus O2 plus H2 gives CH3CHO. This is in the liquid phase, so I will write liquid. This is gas, and this is solid. Let's balance the equation. It will be 2 moles, oxygen will be half, and hydrogen will be 2 moles to get this as 1 mole. Let's calculate delta N. Delta N is equal to, this is in the liquid state, so I will not consider this. So 0 minus, if I see this, this is solid, I will not consider. So only those 2 will be considered. 2 plus half is 2.5. So the answer here is minus 2.5. So here the answer is second option. Let's see the next one. H2 plus Cl2 gives 2 HCl. Here the delta H value is given. This much delta H is for 2 moles of HCl. Students, you know 1 mole of HCl corresponds to 36.5 gram. Therefore, 2 moles will correspond to this multiplied by 2. How much it comes out to is 73 gram. So, let us read the question. They are asking you to calculate for 0.365 kg. 0.365 kg means 365 gram. So, let's make an equation. For 73 gram, the energy which is released is 184, but for 365 it will be how much? If you cross multiply this, you will get 365 multiplied by 184 by 73. So the answer comes out to minus 920. But if you read the question, they are asking how much energy is absorbed. So delta H will be positive. So your answer will be plus 920 kg. So the answer here is first option. Let's see the next question. Next question, they are asking the Kirchhoff's equation. Students, Kirchhoff's equation is the only equation that gives the relation between enthalpy change, internal energy change with respect to temperature. What is that Kirchhoff's equation? So let us see that. I'm writing for enthalpy change. So delta H2 is equal to delta H1 plus delta Cp T2 minus T1. Now here 1 indicates the initial condition and 2 indicates the final condition. Delta Cp is the molar heat capacity at constant pressure. If I rearrange this equation, I'll get delta Cp is equal to delta H2 minus delta H1 upon T2 minus T1. This is one of the form of Kirchhoff's equation. If I put the same equation in terms at constant volume, this is at constant pressure. So if I write at constant volume, it will be delta Cv is equal to heat at constant volume is internal energy change. So it will be delta U2 minus delta U1 upon T2 minus T1. This is the second equation. So let's see the options. According to the options, they have given only one related to delta Cp. So answer here is third option. Let's see the next question. Heat of combustion of methane is minus 800. Let's first write the combustion reaction of methane. What is combustion, student? Burning methane in excess of oxygen. So write the equation. CH4 gas plus O2 gas gives combustion products. They are always carbon dioxide and water. So this is the equation. Let's try to balance this. It will be 2 moles of oxygen with 2 moles of water. This is the balanced equation. They say that the heat of combustion of methane is minus 800 gram. So what will be the heat of combustion for 4 into 10 raised to minus 4 kg of methane? So students, if you see this, here 16 gram of methane is utilized. For 16 gram, the energy which is released is minus 800. Therefore, for 4 into 10 raised to minus 4, it will be how much? Let's cross multiply this. But if you see this they have given this in kg. So I'll convert this also in kg. So let's cross multiply this. What you get? 4 multiplied by 10 raised to minus 4 into minus 800 upon 16 into 10 raised to minus 3. So if you solve this, answer will come to minus 20 kg. So here the answer is third option. Let's see the next question. 16 gram of oxygen. If 16 gram is given, molar mass of oxygen is 32. Therefore, number of moles will be 0.5. Expands isothermally and reversibly at 300 Kelvin. Temperature is 300. V1 is 10 dm cube and V2 is 100 dm cube. So here they have given isothermally and reversibly. So equation will be of W max. So W max is equal to minus 2.303 N. I will substitute 0.5 R. Now if you see the values, R will be 8.314 multiplied by 300, that is temperature, multiplied by log to the base 10 of V2 by V1. If I cancel this, I will get log 10. Log 10 is 1. So let us do this. That is minus 2.303 multiplied by 0.5 multiplied by 8.314 into 300. So if you solve this, answer is minus 2872. So the answer here is nearly second option. Let's see the next one. At the same conditions of pressure, volume and temperature, work done is maximum for which of the following gases? Students, in this type of question, let us first calculate the molar mass, because the mass of the both the gases, all the gases, they are same. So the first gas what they have given is ammonia, which is 17 gram, nitrogen is 28 gram, chlorine gas is 71 gram and H2S is 34 gram. If you see this, the lightest is this. So students, always remember, work done is inversely proportional to its molar mass. So maximum work will be done with the gas which is lightest, and therefore the answer is first option. Let's see the next one. In dash process, work is done at the expense of internal energy. If it is a non-flow process which is carried out adiabatically, then according to the equation what we have, delta U is equal to Q plus W. If it is adiabatically, this will be 0. So whatever the work will be done will be only at the expense of internal energy. And they are saying that the work is done at the expense of internal energy. So it must be adiabatic process where Q is equal to 0. So answer here is third option. Let's see the next one. In an isothermal and reversible process, 1.6 into 10 raised to minus 2 kg means 16 gram of oxygen, means number of moles are again 0.5, expands from V1 is 10, V2 is 100. So log to the base 10 of 100 by 10, this will come to 1. Temperature is 300. So student, the calculation is same what we have solved here. So it will be this, that is answer will be again minus 2872. So question is repeated. Here the answer will be minus 2873. So answer here is second option. Let's see the next one. The heat of formation of water is 260 kJ. If they are giving this for water, means it is for 1 mole. So for 1 mole, how much is this? 260 kJ of energy is released for 1 mole. Then they are asking for 130. So 130 kJ will be given by how many moles? If you see the relation, it's exactly half. So this will be for half mole. So answer is third option. Let's see the next question. Which among the following thermochemical equations represents the formation of sodium chloride? Students, whenever it is formation of any compound, that compound should always be formed as 1 mole. If I see the options, here I have where it is 1 mole and here I have where it is 1 mole. Second important thing is, whenever this type of formation reactions takes place, it is always the formation of 1 mole from it elemental constituent atoms. So they are not constituent atoms. So constituent atoms are sodium in the solid state and chlorine in the gaseous state. So answer here is fourth option. Let's see the next one. Correct representation of heat supplied at constant pressure and volume can be given as. Now what is the equation for this student? The equation is delta H is equal to delta U plus delta N RT. What is delta H? Delta H is H2 minus H1. What is delta U? Is U2 minus U1. And what is this? I can write it as N2 minus N1 RT. If I open this, H2 minus H1 is equal to U2 minus U1 plus this will be N2 RT minus N1 RT. Now taking into considering the values, if I check H2 minus H1 and if I bring this to this side, it will become U2 minus U1. So if you see the options here, according to this, I think option will be third option. Let's see the next question. The heat of combustion of carbon is this much. So let's write the reaction. Combustion means C plus O2 giving CO2. For this, how much carbon dioxide is formed? 44 gram is formed. So for 44 gram of carbon dioxide, the energy which is released is minus 393.5. Therefore, for 35.2 gram, it will be how much? Just cross multiply this, you will get the answer as minus 316.4. So the answer here is third option. I hope you have understood all the questions. So please do like this video, share it with your friends and don't forget to subscribe to my channel to get more videos. Thank you students.